Hey everyone, welcome to the session on CI/CD Anywhere. In this session, we'll be discussing why CI/CD Anywhere matters and how we're helping customers streamline their build, test, and deploy processes across cloud and on-premise environments. My name is Damith Karunaratne, and I'm a Senior Product Manager at Google Cloud. And this is my colleague, Ben Huston, who is a Kubernetes specialist at Google Cloud. Today, we will be speaking to you about Google's new approach to doing CI/CD anywhere. Before I dive into product details, I'd like to turn it over to Ben. He's going to give a quick overview on why a hybrid approach to CI/CD is such a hot topic these days.
Damith, thanks for the great introduction. Now, to those of you in the audience, I have an important question for you. Why should we care about being able to do continuous integration and continuous delivery anywhere? Well, we should care because CI/CD flexibility is an extremely important topic right now. This is due to the fact that enterprises need build processes that can keep pace with constantly changing business, regulatory, and security requirements, and which work across multiple environments they have made massive investments in. More specifically, enterprises need transformational development capabilities like build anywhere and deploy anywhere, because these can support massive on-demand scale-up, are inherently resilient and highly available, can be authored and managed in a completely version declarative manner, and are instrumented with out-of-the-box tooling, which provides end-to-end observability across the entire build system. Unfortunately, most enterprises still use inflexible legacy build tools like Jenkins, which predate the cloud. These tools simply can't meet enterprises' current needs because they don't provide a uniform way to do continuous integration or continuous delivery across different environments. And they also can't easily scale to accommodate the type of extremely high volume, high concurrency CI/CD that dominates modern software development. The good news is that most of the performance problems which have traditionally plagued build systems have been solved in recent years by Kubernetes, which is an extremely popular orchestration framework for operating systems at massive scale. The most highly sought after at-scale system attributes, such as flexibility, scalability, resilience, control, and performance, are now provided out of the box by the Kubernetes API, its unique approach to distributed application lifecycle management. Next-gen build tools, like the one that my colleague Damith will introduce next, understand they do not need to reinvent the wheel. These tools explicitly harness the power of the Kubernetes API and extend it with rich new primitives specifically designed to address the most difficult CI/CD use cases. Now that I've explained why Kubernetes is such a big deal for modern CI/CD, let me turn the floor back to Damith to introduce Google's new approach to CI/CD Anywhere.
Thanks, Ben. With all of this in mind, I'd like to introduce Cloud Build Hybrid. With Cloud Build Hybrid, Google Cloud is taking the power, flexibility, and simplicity of Google Cloud Build and bringing it to anywhere you can run Kubernetes. Cloud Build Hybrid is powered by Tekton, which means out of the box, you avoid vendor lock-in and get the reliability that you've come to expect from Kubernetes. Capabilities like self-healing and graceful failover allow for no single point of failure. Being able to run directly on your infrastructure behind your firewalls now means you can get the advantages of cloud-native CI/CD for workloads that can't easily be moved to the cloud. But Cloud Build Hybrid is not only about providing the benefits of Kubernetes and Tekton. Since this is an extension of Google Cloud Build Hybrid provides you a consistent interface and workflow for building and deploying your applications. You can seamlessly switch between using the fully managed or hybrid version of Cloud Build without having to change your workflow. You also get a single pane of glass through the existing Cloud Build interface, so you can easily see activity across all your CI/CD environments in one place, regardless of whether you're using the fully managed or hybrid version. With Cloud Build's developer-centric syntax, you're able to easily define your CI/CD workloads without having advanced knowledge of Kubernetes. So developers can spend more time on building and delivering software that drives the business. And upgrades have never been easier. All Cloud Build Hybrid instances can be centrally managed, which includes automated updates and patches to make sure you're always secure. In addition to this, with a Google Managed Control Plane, you get the availability and support your business relies on to ensure smooth operation. With Cloud Build Hybrid, we handle the complexity of multi-environment CI/CD. Just add environment configuration to your Cloud Build YAML, and your pipelines will easily and transparently run the workload against registered Kubernetes environments, regardless of where they're located. Scaling these workloads across your environment is also simplified. Cloud Build Hybrid harnesses the power of Kubernetes to provide robust auto-scaling and concurrency for all your CI/CD processes. Not only is scaling simplified, but it's also more efficient with resource pooling. All workloads are entirely containerized and managed using Kubernetes, allowing them to be scheduled right alongside non-CI/CD workloads. Workloads also run completely hermetically, ensuring that no build-time dependencies ever cross-contaminate the runtime dependencies relied upon by other co-located workloads. For hard-to-update, resource-constrained on-premise environments, this scheduling fungibility is extremely valuable. Now, let's take a peek under the hood to see how this works. On the left, we have Google Cloud and the fully managed control plane. On the right, we have a hybrid multi-cloud environment running a Kubernetes cluster. With Google Cloud's Connect service, we can connect a Kubernetes cluster to the Google Cloud control plane. Doing this will install the Connect agent, which will allow the control plane to communicate with the cluster. Once the cluster is connected, we can enable the Cloud Build feature and install hybrid worker pools. These hybrid worker pools consist of Tecton and some additional components and configuration that make interacting with Google Cloud seamless. Once hybrid worker pools are installed, Cloud IAM will need to be configured for Cloud Build service accounts to properly communicate with the worker pool. And finally, we'll need to make sure that the Kubernetes service account on the worker pool is configured to interact with our source control and artifact repositories. Once Cloud Build Hybrid is set up, you can leverage the same Cloud Build workflow as the fully managed offering to build, test, and deploy your applications. Your workload is executed as a series of build steps, which are defined as containers we call builders. Since each build step is hermetic and only exists for the duration of the step, any data that you wish to share across steps can be shared through a common workspace. Google Cloud provides a set of fully supported and maintained builders for a variety of workloads, but there are also over 100 community builders available. You can also create your own builder to address unique use cases. This workflow can not only be used to build containers, but also non-containers, such as Java or Go artifacts or golden VM images. The Cloud Build syntax remains the same for executing workloads on hybrid worker pools. All you need to do is specify the hybrid pool that's going to execute the workload. For instance, in this Hello World example, which has 6 lines of code, we specify the hybrid pool that the build is going to run on. This build will be transformed into a Tecton task run before it's sent to the hybrid worker pool with optional support for Docker and Docker builds. There's a large community that uses Docker today, and we want to make sure the experience for the Docker community is as seamless as possible. This means they don't have to worry about the overhead of orchestrating Docker and Docker build processes in Kubernetes, since we take care of this based on the hybrid pool configuration. The resulting Tecton task run in this example, which executes a Docker and Docker build, ends up being 156 lines. This translates to roughly 26 times more lines of code. We're taking care of the boilerplate and Kubernetes configuration required to run this build, while integrating it with Google Cloud services such as Cloud IAM, Cloud Logging, and source control integrations. This allows developers to focus on building great software and not worry about the underlying technologies running their CI/CD workloads across all their environments. Cloud Build and Cloud Build Hybrid are part of a much broader end-to-end GCP DevOps toolchain. Some of these platforms and services will be highlighted in the demo that Ben is about to show you. Ben, over to you.
Thanks, Damith. Awesome product overview. And I'm going to quickly walk through the logical flow of a short demo we've prepared. First, we'll see a developer check new code into version control. Next, we'll see Cloud Build Hybrid detect the code change and begin to kick off builds. Then, we'll see 4 processes concurrently building and deploying the same application to 4 different target environments: GKE, Anthos attached clusters on AWS and Azure, and an Anthos bare metal cluster which is running on-premise. Finally, we'll see the overall build progress being monitored with built-in tooling, like the Cloud Operations Suite and Cloud Build dashboards. Okay, on to the demo. All right, we are now ready for a quick demo of Cloud Build Hybrid. Here we see 4 different types of Kubernetes clusters registered with the Google Cloud Control Plane: a GKE cluster, 2 Anthos attached clusters for EKS and AKS, and an Anthos bare metal cluster that is running on-premise. The great news is that once you register a cluster with Google Cloud, installing Cloud Build Hybrid is dead simple. Now we're going to open a Cloud Shell session and run a quick CLI command to confirm that our cluster is ready for action. Yep, the install status is okay across the board. Okay, now that the environment overview is out of the way, let's quickly explain how Cloud Build Hybrid jobs get queued. Cloud Build Hybrid uses a configuration construct called the trigger to associate a build event like a pull request with a build pipeline and kickstart the build process. Here you can see we have 4 triggers defined, one for each of our Kubernetes clusters. In a moment, we're going to switch to an IDE, aka an interactive development environment, where we'll commit a config change and push it to our Git repo. Afterwards, the triggers we've defined here, we'll listen for this commit and then kick off a Cloud Build Hybrid job for each of our environments. In our IDE, we see 3 important files: cloudbuild.yaml, deployment.yaml, and a Docker file. Cloudbuild.yaml defines our build pipeline. Here you can see that we've defined 3 steps: build image, push image, and deploy to a cluster. Next, the deployment.yaml contains our Kubernetes deployment configuration. Here we see that a Kubernetes service account, a deployment, and a horizontal pod autoscaler have been defined. Finally, the Docker file shows what is baked into our container image. Here we pull an upstream Nginx image, run an awesome echo statement, and then take a nap. To show Cloud Build Hybrid in action, we're going to increase the sleep to 11 seconds, and then commit and push this change. Now that our code is committed, we'll switch back to the GCP console, where we see 4 new builds have been scheduled. Each build corresponds to one of the triggers we showed earlier, one for Google Cloud, AWS, Azure, and on-premises. Importantly, both the CI and the CD steps are happening at the same time within each cluster using Tecton. Now that a few minutes have passed, we'll see that our builds are starting to complete. Next, we're going to click on one of these builds to see what that looks like. Here we can see 3 build steps: build, push, and deploy, and our build logs. We can also see metadata related to the build. For example, we can see that it ran on hybrid worker pool GKE cluster 1. Finally, I want to show you something else that's pretty cool about Cloud Build Hybrid. If you want to do a deep analysis of your build logs, these are already pre-integrated with Cloud Logging. This means that all of your build logs are already defined with a powerful common expression language that you can modify as you see fit and then use to rerun your queries. This allows you to easily dive in and explore any complex build errors you might run into. Now that our builds are finished, I want to show you one more important thing. When we explore the build for another cloud, like AWS, we see that the build interface looks identical to the one we just saw for GKE, which is totally awesome. Now it's time to check the status of the workloads we just deployed. In the Google Cloud Console, we see a screen that shows what workloads existed in the default Kubernetes namespace of our clusters before we committed new code. Hitting refresh shows that we now see 4 new Nginx apps running across Google Cloud, AWS, Azure, and on-premise. Now, just for fun, let's confirm what the dashboard for a few other cloud providers show us. Hitting refresh in EKS shows the same workload, deployed about 5 minutes ago. The view from the AKS dashboard tells the exact same story. Same workload again, this time it's 4 minutes old. And now we've reached the end of our demo. We've seen how Cloud Build Hybrid can be used to both build and deploy apps across multiple environments using Tekton-powered Kubernetes awesomeness and slick Google tooling. Enjoy.
Thanks for the great demo, Ben. To quickly recap, you just saw Ben show how Cloud Build Hybrid provides a unified CI/CD experience that abstracts away the complexities of cloud-native CI/CD with Kubernetes while providing the flexibility to build, test, and deploy to any environment. Google Cloud's fully managed control plane provides a single pane of glass to gain visibility into all your workloads, regardless of where they're running. Finally, Cloud Build Hybrid harnesses the power of Kubernetes and Tekton to run your workloads reliably at scale. All of this will be available in public preview later this quarter. In the meantime, to learn more about Cloud Build, take a look at the Cloud Build documentation. And don't forget to check out some of the other sessions on Cloud Build, Cloud Deploy, and securing your software delivery pipeline. Thanks for tuning in and learning about Google Cloud's approach to CI/CD anywhere. Enjoy the rest of Google Cloud Next.